Hello everyone, this is Jared Johnson with the Bryan County Emergency Management Agency. In this video, I'd like to share some information with you over severe weather preparedness and talk about different types of severe weather that we may see in our area. I'd also like to share some information with you over weather radars, how they work, and some of the limitations that we're seeing with weather radars, and also talk to you about weather safety. The following information is available on the National Weather Service website. If you go to weather.gov and you look up NWS weather radar, how radars work, you should be able to find this page. I'd like to provide some basic information to you on how radars work. Radars work by sending out a beam of energy called radio waves, and these beams are emitted through an antenna. As these beams strike objects in the atmosphere, the energy is scattered in all directions, with some of the energy reflected back to the radar. Radar stands for radio detection and ranging. The larger the object, the greater the amount of energy that is returned to the radar. This provides the Weather Service with the ability to see raindrops in the atmosphere. In addition, the time that it takes for the beam of energy to be transmitted and returned to the radar also provides the Weather Service with the distance to that object. Over time, we have seen a variety of new developments and improvements in weather radar technology. Weather radars continue to be a very valuable tool for us to utilize. There are, though, some limitations in weather radars I'd like to share with you. Earlier this year, I had a chance to go to a presentation, and there are a few representatives from Climavision. This page that you're seeing on the screen is from climavision.com/resources/what-is-weather-radar-guide. On this page, there's a variety of really good information on some of the coverage limitations, along with some information on different types of radars. The infographic that you see on the screen is information on some of the low-level coverage limitations. When the radar is sending out its beam over miles of distance, there are some challenges where you start to see low-level coverage gaps. So the farther away you are from the radar, it's harder for the Weather Service to be able to see if there is something close to the ground, and that has caused some issues. Specifically this summer in O'Brien County, we had an EF0 tornado earlier in the summer that we had no watch or warning for. Some of these land spouts and cold air funnels may not be visible on a weather radar, so it's important to have the understanding over how radars work, to know as you go farther out from the weather radar, there are some gaps that they cannot see closer to the ground. The following information is available on the National Weather Service website. I'd like to provide some information to you on non-supercell tornadoes called landspouts. Landspouts can occur in cumuliform clouds without the parent cloud rotating. Typically, these occur along weather boundaries where air converges under weak vertical rotation, and the convergence of the air at the boundary forces it up, forming a cloud, and this updraft stretches the rotation, increasing its spin. Tornadoes from these typically occur during summertime thunderstorms, and their appearance is usually long and slender and snake-like. The danger with these are landspouts may not be visible on a weather radar. It can be very challenging to see landspouts, but they can still produce significant tornado damage up to EF2 and EF3 damage. So it's important to know what a landspout is in case you come across something like this.